Hello everyone, welcome back to my YouTube channel Physics Unification. In the last two parts, we discussed some 3 marks and 5 marks derivation from the chapter Current Electricity. Let us see some definitions and some derivations from this topic. First of all, what do you mean by cell, electromotive force, internal resistance? We have to know. Cells, a simple device to maintain a steady current in an electric circuit, is called as electrolytic cell. Usually, cell has two electrodes. One is positive electrode, another one is negative electrode. The positive electrode has a potential difference of V plus, that is greater than 0, between itself and the electrolytic solution. Negative electrodes which develops a negative potential V minus, that is V minus, which is also greater than or equal to 0, which is related to the electrolyte and itself. When there is no current applied, then what happens? Electrolyte has the same potential throughout, so that the potential difference between P, positive electrode P, and negative electrode N is equals to V plus V minus. Therefore, the difference what we will get now, that one is called it as electromotive force, EMF of the cell, and that can be denoted it as E. E is equals to V plus V minus, that should be always greater than 0. Then what do you mean by electromotive force? Electromotive force or EMF is the potential difference between the positive and negative electrodes in an open circuit. That is when no current is flowing through the cell. Internal resistance, it is the resistance offered by the electrolyte of the cell when the electric current flows through it. The terminal potential difference, the potential difference between the terminals of a cell when current is drawn from the cell is called the terminal potential difference. Here, EMF is always greater than the terminal potential difference. That is, EMF is greater than V. Now, let us derive the derivation of expression for current drawn by external resistor. Consider an external resistor of resistance R which are connected to the cell, and R be the internal resistance of the cell and I be the current flowing through the cell. First of all, when there is no current flowing through the circuit, then potential difference itself gives the electromotive force. Then E electromotive force can be written it as potential difference across positive electrode plus potential difference across negative electrode. When current flows through the cell, then potential difference between positive electrode and negative electrode gives value V equal to V plus positive electrode value plus V minus potential difference across negative electrode minus of I into R. Then V is equals to V plus V minus value is equals to electromotive force E. Therefore, potential difference between P and N gives V equals to E minus I into R. The negative sign in the expression minus of I into R, which is because of current I flows from B to A in the electrolyte in the diagram. Now, according to Ohm's law, V equal to I into R. We know that is when equation 1 and equation 2 implies equation 1 equal to equation 2, it becomes I into R is equals to E minus I into R. Here collect IR term on left hand side only, then what we will get? IR plus I small r is equals to E. Just take I common here, then what we will get? R plus small r is equals to E. Here I is equals to E divided by R plus small r, and this one is the expression for current drawn by external resistor R. When there is maximum current drawn from the cell, then I max gives the value E divided by small r, because R is equals to capital R equal to 0. Maximum current drawn from the cell means that cell is short circuited, then which gives the value capital R equal to 0. So I max is equals to E divided by small r. In most cells, the maximum allowed current is much more less than E divided by small r to prevent permanent damage to the cell. And this derivation is very important for 3 marks. Let us see the derivation of cells in series. To increase the voltage or EMF or potential difference, a number of cells to be connected in series. Here, let us consider two EMFs E1 and E2 which are connected in series. R1 and R2 are the internal resistance. I be the current flowing through the cell. Let V of A, V of B and V of C are the potential across the points A, B, C. V of A minus V of B is the potential difference between the positive and negative terminals of the first shell. Then VAB, that is V of A minus V of B, is equals to E1 minus I into R1. Similarly, V of B minus V of C is the potential difference between the positive and negative terminals of the second cell. Then VBC is equals to V of B minus V of C, which is equals to the value of E2 minus I into R2. Hence, potential difference between positive and negative terminals of the combination. Here, two cells are connected in series and this one is replaced by the equivalent EMF E and the equivalent resistance R in the combination. Then potential difference becomes VAC is equals to V of A minus V of C, which is equals to the value of V of A minus V of B plus V of B minus V of C value. Here VAB, that is VA minus VB value, is equals to the E1 minus I R1 and VB minus VC value is equals to the value for E2 minus I R2. This VAC. Then just by simplification, what we can write, E1 plus E2. Here minus I is common, just take outside, then inside the bracket what we will get, sorry, it should be equal to R1. R1 plus R2. Now by combination cell, VAC can be written as A equivalent minus I into R equivalent. Equation 2. Comparing equation 1 and 2, what we will conclude, E equivalent is equals to the value of E1 plus E2 and R equivalent is equals to R1 plus R2. If there is n number of cells, then E equivalent can be written as E1 plus E2 plus E3 so on up to En, and R equivalent internal resistance. Equivalent internal resistance can be written it as sum of individual internal resistances, that is R1 plus R2 plus R3 so on up to Rn. And this derivation is important for 5 marks. Let us derive the expression for cells in parallel. To increase the current, number of cells are joined in parallel. In series combination, what we will get? Maximum value of potential difference or EMF. Consider two cells having EMFs E1, E2 and internal resistance R1 and R2 which are connected in parallel. I1, I2 are the currents leaving the positive electrodes of the cell. At the point B1, I1 and I2 flows in, whereas the current I flows out. Thus, at the point B1, what we will get? I is equals to currents leaving the junction is equals to the current entering the junction, which is by Kirchhoff's current law. V of B1 and V of B2 be the potentials at the point B1 and B2 respectively. Considering the first cell E1, then the potential difference across the terminals can be written as V is equals to V of B1 minus V of B2. V is equals to E1 minus I into R1. Thus the potential difference across the first cell is equals to V is equals to E1 minus I1 into R1. Then value of I1 becomes E1 minus V divided by R1, taken as equation 1. Similarly, for the second cell, potential difference V equal to E2 minus I2 into R2. In the similar way, I2 can be written as E2 minus V divided by R2. Now substitute I1 and I2 value in the expression I is equals to I1 plus I2. E1 minus V divided by R1 plus E2 minus V divided by R2, which is equals to E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Therefore, I is equals to E1 by R1 plus E2 by R2 minus of V into 1 by R1 plus 1 by R2. If you replace the combination by a single cell between the B1 and B2 of EMF, E equivalent and internal resistance are equivalent, then we have potential difference across A and C. A and C is V equal to E equivalent minus I into R equivalent, or value of I becomes E equivalent minus V all divided by R equivalent, or I is equals to E equivalent by R equivalent minus V into 1 divided by R equivalent. Equation 3 and equation 4. Now compare equation 3 and 4. Then what we will get? E equivalent by R equivalent is equals to this value. 1 by R equivalent value is equals to this value. E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2, and R1 divided by R equivalent is equals to 1 divided by R1 plus 1 divided by R2. For n number of cells which are connected in parallel, what we can write? E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2, so on up to En by Rn. And internal resistance 1 by Ren is equals to 1 by R1 plus 1 by R2 plus so on up to 1 divided by Rn. And this derivation is also important for 5 marks. Let us see the problematic part. Two cells of EMF 3 volt and 2 volt, and its internal resistance are 1.5 ohm and 1 ohm respectively, are connected in parallel across 3 ohm resistor such that they tend to send current through resistor in the same direction. Calculate potential difference across 3 ohm resistor. Here given quantity E1 equal to 3 volt, E2 equal to 2 volt, and internal resistance 1.5 ohm R1, R2 equal to 1 ohm, and the same current which flows through the resistance 3 ohm. Here at finally what we have to find out? Potential difference across R. We know how to find out potential difference across R, that is V equal to I into R. We already know the value of R equal to 3 ohm, means what we have to find out? Value of I. But we don't know value of I. How to find out that value of I? We know the formula I equal to E equivalent divided by capital R plus R equivalent. Here we know the value of R only, but we don't know the value of E equivalent and R equivalent. Then before finding the value of V and I, what we have to find out? We have to find out the value of E equivalent and R equivalent. Then how to find out E equivalent value and R equivalent value? We know the formula for that one. First of all, R equivalent equal to R1 R2 divided by R1 plus R2. R1 is 1.5 into R2 is 1 divided by 1.5 plus 1, which is equals to 1.5 into 1 is 1.1, 1.5 divided by 2.5. Then R equivalent is equals to 15 divided by 10 into 25 divided by 10, which cancel each other, which gives the value 5 3s are 5 5s are, which is equals to 3 divided by 5 or 0.6 ohm. Now E equivalent by R equivalent is equals to E1 by R1 plus E2 by R2, which implies E equivalent equal to cross multiplication R equivalent into E1 by R1 plus E2 by R2. Therefore, E equivalent is equals to R equivalent value is 0.6 into E1 value is 3 divided by R1 value is 1.5 plus E2 value is 2 divided by R2 value is 1. Then E equivalent is equals to 0.6 30 divided by 15 plus 2, which implies 0.6 into 15 ones are 15 twos are 2 plus 2 is 4, which gives the value E equivalent is equals to 2.4 volt. Here We know the value of R equivalent and also we know the value of E equivalent. Now what we have to find out? Value of I equal to E equivalent divided by capital R plus R equivalent. Now substitute the value of E equivalent and R equivalent value in this expression. Then we will get the value of I. 2.4 divided by R plus 0.6, which is equals to 2.4 divided by 3.6, or which is equals to 24 divided by 36. 12 2s are 12 3s are, which gives the value 2 divided by 3 amps. Now what we have to find out? Potential difference across 3 ohm resistor. R equal to 3 ohm is V equal to I into R, which is equals to I value is 2 divided by 3 into R value is 3. 3 gets cancel each other. Therefore potential difference across 3 ohm resistor is 2 volt.